So here we are, guys, welcome back. We are ready to create our first transaction. But as you may imagine, to send a transaction, we need at least two addresses, one that sends the funds and one that receives the funds, right? So to create a transaction, we actually need a second, a second address. So for that, we will first create a second payment address, and we are using, as before, the Cardano CLI Shelly address keygen to generate a second key pair so that we can then derive or build a address for that. Okay, so let me just come here and grab, as usual, our Cardano CLI Shelly address keygen to generate that second set of keys. And note that this time I am using payment2 as part of the name file, as part of the name of the file, because if I use the same payment.skey name, I will overwrite my previous keys, right? So I will need to add this different name to my file so that I can have a better control of my two keys. But let me just, for the sake of let me just make sure where I am. Yes, I am here in my keys and addresses folder as I was before, and let me just make sure that I can then execute this command Cardano CLI Shelly address keygen with the different file names. Okay, let me just clear this screen so that we can have a clear one. Okay, so let me just copy and paste this one. And again, no news is good news. And as expected, I have here a payment2 secret key and a payment2 verification key. So we are going in the right path. Let me just now generate or build an address from this. And for that, we are using Cardano CLI Shelly address build command with a set of options. In this case, we are generating a payment2. We are using the payment2 verification key as a verification key file, and we are going to generate an output file which will be payment2 dot address. Okay, and as usual for these exercises we are using testnet magic, which is a parameter that identifies the Shelly testnet. So let me just grab this command and copy and paste it here. No news is good news, and as expected I have now a payment2 dot address, and that is exactly the address to which we are going to send funds. Let me just cut this address. It's payment2, sorry, dot address, and that will be my address here. It's a little bit messy because it joins with my prompt, but it finishes in HA7. Okay, so here we are. So now, to create a transaction, we need to perform a series of steps. It might be a little bit complex the first time you try to do it. What I can recommend is try sending different transactions so that you can get used to the process of creating transactions. It involves a series of steps. First thing we want to do here is to get the protocol parameters. As you remember, those are stated in the Genesis file, but we can also query them using a command which is Cardano CLI, sorry, Shelly, and query, and if I press enter I get the list of probable of available options. And remember here this nice reminder, we need to set the Cardano node socket path. Let me just do it again so that if you don't remember how it was done, we made it when we queried the faucet, or probably here. I'm not sure where we done it, when we done it, but let me just come here to my notepad, which I told you it was very useful because I can simply use this one and paste it here, and now I'm done exporting the Cardano node socket path as an environment variable. Okay, so we will need that. This is a reminder that we get from the help, and we are going to use this particular subcommand, protocol parameters. So again, we come here and Cardano CLI shell query protocol parameters. And let's see what are the available options for this. Okay, I made a tiny mistake here. Parameters. There we go. And here are the options. In this particular case, we are only going to use the testnet magic and the output file. That's all we need for now. And this is what we have here. So I'm just going to grab this command and I'm coming here and pasting it. And if I do ls, now I should have a file called protocol.json. There it is. And if we do cat protocol.json, we can see that it contains all the parameters of the blockchain. Okay? So we will need this file to create our transaction. Let me just come here and clear my screen again. So that now we have the protocol parameters, so we can check that. We need to define now the time to leave of our transaction. What this means? This means that we need to define a slot number for our transaction to be electable to be put into a block, and if the blockchain reaches this slot and our transaction is not yet in a block, it will be cancelled or it will be an invalid transaction. So one thing to notice here, this is an absolute number, the absolute number of the slot that we are looking for. It is not relative, meaning that we are not counting from here n number of slots, but we need to provide the absolute number of the slot count. And for that, first we need to query, again, we are using the query subcommand, we are going to query the current slot number of the blockchain so that we can calculate our TTL, or time to leave. Okay, so to do that, we use Cardano CLI shell query tip, and just with the subcommand or with the option testnet magic 42 to identify the Shelly testnet. So we come here and Cardano CLI shell query tip, and we are going to query the tip of the blockchain. And as you can see, we get as an output a JSON that contains the block number, the header hash, the current header hash of the tip of the blockchain, and the slot number. And this is the number that we are interested in. Okay, so we are looking for, we are now at 634,499. So what we are going to do is add some slots to that number so that we can have a decent window for us to finish building our transaction and submit it to the blockchain. So now, let's say if that we are on 634,499, I'm just gonna give me like a good window for that. So I am going to make my TTL 637,000. 637,000. That will be my TTL, okay? Now, next thing we want to do here is to calculate or determine the transaction fee. But for that, we need to draft a transaction so that the system can estimate what will be the transaction fees for that particular transaction. And since this is a simple transaction, this transaction will have one input, which is the UTXO from which we are going to send funds, and two outputs. One of these outputs is going to be the address to which we are sending funds. And the second output, it is very important, please note this one, you need to give your payment, your origin address again, because you are sending your change back to your own address. So I hope this makes sense. You have one input, which is a UTXO, which belongs to an address, okay? It will send a transaction, if you remember from the UTXO model, we will send some amount to payment 2 address and the change back to payment 1, but it will create a different UTXO. This is why we need to change, to send a change to this same address again, because it will create a different UTXO. Okay, so our transaction will have, coming back here to my tutorial, 1 transaction input, 2 outputs, and for now, since we are just making a draft of our transaction, I can set the TTL to 0 and as well the fee to 0, but one thing that we are going to have as an output is a transaction raw file. This will contain the basics of the transaction so that we can then estimate the fees for that transaction, okay? So let me just grab this and come back again to my notepad because I will need to make some tweaks to this. And I wonder if you are already knowing which tricks I need to make here. And of course, this address is not valid. This is not the UTXO from which I am going to send the funds. So I need to query my balance again so that I can have my balance and my UTXO hash. So for doing that, I need to do Cardano. Oops, control Cardano CLI Shelly query UTXO, and let's remind us about the parameters that this particular command takes. So this particular command will take the address from which we are querying the balance, and right now we only this address and the testnet magic. Okay, so let's use that again. UTXO, we can have like a backslash here so that we can continue inputting options. Let's say address, and for address here is bash is useful again because we can use cat payment address. This will read the content of our payment address and pass it as an argument. Let me use a backslash again, and let me use testnet magic again, 42, and that should be enough to query my UTXO. And there it is. So this is the actual UTXO, which is nothing more than a transaction hash. And let me just add it here. It must be followed by the hash sign and the transaction index, which you get from here. So in this case, it is number 1. And how many ADA do we want to send? Let's say we want to send 100 ADA to our payment to address. So that would be 100 ADA followed by 6 zeros, because this amount is in level S. So just confirming, yeah, it is correct. This amounts for 100 ADA. For now, I'm gonna leave this parameter, this value as 0, because this is just a draft of the transaction. Later on, we will reveal this transaction with the correct amounts, but for now, we can simply just come here and grab this as it is. Also for the TCL and the fee, we don't need it at this moment. The one thing that we need is the name of our output file, which is transaction.raw, okay, tx.raw. So let me come here and let me just clear my screen again and paste that command that we have constructed, and let me do enter. ls, and as you can see here, I have now my tx.raw file, and that is a file that I am going to use to actually calculate the transaction fees that this transaction will incur. So here we have the command for calculating the transaction fees. As you can see, we are now using again Cardano CLI Shelly transaction calculate min fee as a subcommand, and this command takes a set of arguments. The first argument it will take is tx body file, and this body file of the transaction is nothing more than the draft of the transaction that we just created, the tx.raw file that we just created. And it asks for how many inputs does this transaction have, and from here we know that it only has one input, so it's just a natural number here. And how many outputs does this transaction produces? So it will produce two outputs, one to the payment to address and one to our original payment address. So it is a natural number here. Number two, witness count. It is how many keys will sign this transaction, and since our funds are only coming from payment.address, we are adding only one witness to this transaction. Non-Byron witness count, because we are not using any Byron address or keys. Again, our test and magic 42 and the protocols parameter that we queried before. And it will, as an output, produce the transaction fees that we will need to pay for this. Okay, so let me just grab this line here, this command. In this case, I can simply copy and paste from the tutorial because there is nothing here that we need to customize. And let me just press enter, and as you can see here, it is an output, and this output is a transaction fee that we will need to pay. It is 177,337 lovelas. Okay, so now that we have that number, there is some kind of math that we need to do here. We need to calculate how much will be the change that we will need to send back to our original address. So we know that we are sending, let me just grab my notepad here, and let's say expression, and we know from here, we know from here that let me just query the UTXO balance again. So we know from here that we have all these lovelas. This will be our starting amount. From here, we need to deduct the transaction fee, which we have here, 177,337 lovelas, minus the amount of ADA that we want to send to payment to address. That will be 100 ADA, which is stated as this in lovelas, and we can now evaluate this expression in our terminal here. Let me just clear my screen again, and I'm going to evaluate this expression, and the output is the change that I need to send back to payment address number 1, let's say, or without any number, right? Our original address. So let me just grab that amount, come back here to my notepad and paste it here, because now I can build my transaction with all the information stated correctly. So now we have exactly the same command, Cardano CLI Shelly transaction build raw, the same input, which is the transaction hash, the UTXO that we are using, that we know is transaction index number 1, the same output, which is the same 100 ADA, but this time now we know how much we need to send back to our original address, and it will be like this. And we said before that we were going to use for our TTL, let me just query that again just to make sure that we haven't reached that. Let me just query the tip again just very quickly. So it is 635 now. We can safely use 637. And for the transaction fees, we know it is 177,337. And we will overwrite our tx.raw file. So now we have everything we need. And here we go. We can run that command again. And now we have a transaction raw file that contains all the information that we need. So now we are ready to sign that transaction. And to sign the transaction, we use another command, which is Cardano Shelley transaction sign. And it takes as an input our transaction body file, which is the transaction raw file that we have just created. And we will sign this transaction with our signing key for our payment address, okay? We need to sign this transaction, and we are using also our test and magic 42 parameter, and we will create an output file which will be tx.signed, okay? So let me just grab this command again. There's nothing that I need to customize here unless you have used a different file name for your payment secret key. You will need to customize, but if you have just used the names, you can simply come here and paste this command and run it. And if I do ls here, as you can see, I have this tx.signed file that is newly created. We can skip this part because we have already created our environment variable. And the last part will be to submit the transaction. So again, we can simply come here and copy the command that in this case is Cardano CLI Shelley transaction submit, and it will take as an input this time the transaction.signed and nothing more than the testnet magic 42, no output file in this case. Okay, let me just come here and paste it. It's not working and didn't copy it, so let me just copy that and come here and paste it. So transaction submit, and no news here is usually good news. If there is an error on your transaction, you will give an error. You will have an error here, and there is a section here that we have created for you to have an idea on how to diagnose, or a first idea on how to diagnose your problems with transaction. It is called diagnosing transactions. So you can troubleshoot your transactions if there is any problem while creating them. So the next thing to do here is to evaluate or to check if this transaction is already in a block and it has been successful. And to do so, we need to query our balances again. And let me just do that with this command that we have used before. I'm going to query the UTXO balance for payment.address, and later on I'm going to query the balance for payment to address. Okay, so let me do the first address. This is the address from where the funds came out, and it may take a few seconds or a few minutes for your transaction to actually get into a block. You may need to query this a couple of times, and it will take a few minutes for this transaction to be included in a block. Let me just clear that screen again and wait a few seconds, and I will be back with you in a second when this transaction is completed. So here we are, a few minutes have passed and our transaction should be already in the blockchain. Let me just query that balance again, and as you can see here, payment.address has a new balance. It is 998 and change. So we have successfully created a transaction. And just to confirm, let me just query the same balance, but this time not for payment address, but for payment to. And as you can see here, we have successfully sent 100 ADA to payment to address. So this is how you create a transaction. As you can see here, it involves a lot of tiny steps, and what I encourage you to do is like send several transactions to get used to the process, and at the end it will be very simple and very straightforward for you. But at the beginning you still need to struggle a little bit with some error messages that you will very likely get. But once you are familiar with the process, you will be very like aficionado, right? You will be comfortable with this process. So this is it for how to send a transaction, guys. See you in the next video, where we are going to talk about stake addresses and stake keys, the other part, the other side of the coin. So see you there.